This is that third problem that I wanted to do in the video, the example problem video for area between two curves, but I thought that video was getting a little too long, so I decided I was going to make another video for example problems for area between two curves, this one, and I would do this third problem that I really wanted to do. And here you go. Here is the graph that we drew at the last problem in the first example video. Because this problem involves sine of x and cosine of x, just like the previous problem. However, the limits are different, and that will prove to be to kind of be a problem. It's going to make this a lot more difficult than the second problem, the previous problem. Okay, let's get into this. So, this is the old graph of sine of x and cosine of x. Okay, so pi over 2 and 3 pi over 2 are the curves that, the limits of our areas, boundaries, regions. The region that we're going to be finding the area of. So where is pi over 2 on this graph? Well, this is 0, right? And then this is pi, and this is 2 pi. So pi over 2, okay, this is pi, this is 0. Pi over 2 is in between, or right there. It's the midpoint, I guess, of that region. Okay, so that's the lower boundary, the farthest to the left area, edge of the area, region, and 3 pi over 2. Okay, so it's pi, 2 pi, right? 3 pi over 2 is less than 2 pi, so 3 pi over 2 is in between, halfway in between pi and 2 pi there, so it's going to be here. Okay, so the area we're finding, take a look at this. It's almost like it's two regions. So the area we're finding is this and this. Okay, that's pretty cool, right? So a lot of students will make the mistake of using the definite integral to find this area, the definite integral being pi over 2 to 3 pi over 2, like this, and then say sine x minus cosine of x dx or something, and or maybe they'll say instead, maybe they'll say cosine x minus sine of x. I don't know. My point is that they're wrong when they say this. Why are they wrong? Because you actually need two integrals. You need two different integrals in order to evaluate this area. Why do you need two different integrals? Because the top curve changes. See, for the first region shaded in yellow, there, the top curve is the greenish-brownish curve, sine of x. Sine of x is the top curve, and the bottom curve is cosine of x. And then for the second region here, the top curve is cosine of x, and the bottom curve is sine of x. First region, top curve is sine. Second region, top curve is cosine. Because the top curve is changing over these two regions, you need two separate integrals. Because the top curve always has to be the first function, has to be that first function in the difference in the integrand of, your area integral, right? So you're going to need two separate integrals in order to evaluate this area. You will see exactly what I mean. So, what are our integrals going to look like? Bottom limit, so let's do this area first. The bottom limit is that furthest to the left, the black line, which is at x equals pi over 2, right? So the bottom limit is pi over 2, and then the next one is, the next limit is where the two curves intersect. In other words, this point, what is that point? That's where sine of x equals cosine of x, which you might think, oh, pi over 4, but that's actually that point. We're looking for the next point, that one, the next point where sine and cosine equal each other. And you might want to, you could divide both sides by cosine, and you get tan x equals 1. Right, and then you could solve this equation instead if you wanted to. If you don't want to solve this one, you could solve the tangent one. I don't know, however you want to do it. And you could solve it with unit circles, solve it with your calculator, whatever. The answer ends up being 5 pi over 4. That is that point. And so that is your second limit. 5 pi over 4. And their top curve here is the greenish-brownish one, which is sine of x. And so, this is what you got. Okay? Plus, because you're going to need to add it to the area of this curve, and that's how you're going to get the total area, plus, okay, another integral. And what is the limit, the bottom limit for this new integral going to look like? The bottom limit here is 5 pi over 4 again, right? Because we're at the intersection point. So 5 pi over 4. And then what's the top limit going to be? It's the line furthest to the right, which is 3 pi over 2. And so there you go, 3 pi over 2. And so, and your top curve is the blue curve, which is cosine. And your bottom curve is sine. dx. Cool. And so your answer is the sum of these integrals evaluated, which I'm not going to make you sit through the evaluations of these integrals because in the previous problem I already evaluated an integral that involves sine and cosine. And I'm just not going to make you sit through that, and I really don't want to do that because I think you know how to do these definite integrals by now anyway. You could probably solve any definite integral that would be asked you by this point, from what you've learned so far in your class probably. Anyway, so with these integrals, when you evaluate them, you end up getting 2.414 for the first one, and then the second one you get 0.414, which if you sum those up, 2.828, right? Okay, and there you go. That is your answer. This is the area of these two integrals, which represent the area of the shaded yellow region. We had to use two different integrals because the top curve changed. The curves on top and on bottom, those changed. They switched. And so we had to do two different integrals in order to find the area. You will see this happen sometimes in calculus in your problems, so it's important to know how to solve one of these problems and recognize them when they pop up. Okay, there you go.